So here is another example on how to solve the linear coupled differential equations. So let's just take quickly the example that they're given. So this question is the find out the eigenvalues of the matrix 1, 3, 2, and 2. So you can just take, if my matrix is A, B, C, and D, the eigenvalue is given by A minus lambda, B, C, and D minus lambda, determinant equals to 0. If you didn't understand this, you can watch my previous videos. Now, what I do is, in case of my given matrix 1, 3, 2, and 2, I'm just going to do 1 minus lambda, 3, 2, and 2 minus lambda. Determinant is 0. I get 1 minus lambda, 2 minus lambda, minus 6 equals to 0. Open up the bracket, you get 1. So 2 minus lambda minus 2 lambda plus lambda square minus 6 equals to 0. So you get lambda square minus 6 lambda. And 2 minus 4 is actually 2 minus 6, that is negative 4. So this is negative 3 lambda actually, so equals to 0. So if you factor this out, you get lambda square minus 4 lambda plus lambda minus 4 equals to 0. So that gives you lambda as positive 4 and lambda is negative 1. So eigenvalue I got is this. Now to get the eigenvectors, what I got to do is, so this is eigenvalue. And now let's see when you solve for eigenvectors. I plug lambda as 4 here, so I get negative 3, 3, 2, and if I put 4 here, so I get negative 2. And times, let's say, x and y equals to 0. This is the procedure to find eigenvector, where x and y is eigenvector, which is different from this and x and y. So just to find out the eigenvector, I get negative 3x plus 3y, rise and dive. So you get run and dive. So I get is, now if I take, so y is basically x. In this case, if I take x is t, y is also t. And if I write in parametric forms, it is 1 and 1 times t. So eigenvector I can take is 1 and 1, 2 and 2, 3 and 3, anything you want. Now when I take lambda as negative 1, so it just quickly write in the value. So when lambda is 4, my vector is 1 and 1. When I take lambda is minus 1 here, I get, let's say, this value is going to be, I'm just going to make the changes here. So when I take lambda as negative 1, I get this value as 2, 3, 2, and 3. So I get 2x plus 2x plus. Now I'll just quickly write down this part here. So 2x plus 3y equals to 0. So I get y is negative 2/3 of x. So how do I find out the eigenvectors here? So if I take x is t, if I take x is t, I get is y is negative 2/3 t. So I can take the vector as 1 and negative 2/3, or if I multiply it times t. If I multiply this by 3, I get 3 and negative 2 as my vector. So I can take this whole number, that's much more easier. So when I take lambda is negative 1, my eigenvector is 3 and negative 2. So now let's find out the general solution of this equation. So as we know, the general solution is given by x and y, basically. This, as I said, this x and y is different. This is just to find out the eigenvector. This x and y is the general solution of this differential equation. So it is the a plus, so a times e to the power lambda 1, which is, that's 4 times 1 and 1, and it is t here, plus b times e to the power lambda 2, which is the second vector is second, this is 1, negative 1, so e to the power lambda 2t, and times the vector is 3 and negative 2.